So this, I don't expect this is exactly how computers work, but this is the sort of thing that they do. So the two algorithms I'm going to teach you are the bubble sort and the quick sort. There do exist other sorting algorithms. The shuttle sort is an example of one, but you don't need to know them. The two that you need to know to be able to do are bubble sort and quick sort. Some of the further algorithms further down the line will require lists to be sorted into ascending order, descending order, unless it specifically asks you to use the bubble sort or the quick sort. In those cases, you can just put it in. The first one we'll look at is the bubble sort. It's probably best done from an example rather than talking through all of this. So here we've got a list of numbers and we've been asked to sort them into ascending order. First things first, make sure you read the question carefully and see whether it wants to go up or going down. So this is going from smallest to biggest because it's ascending order. And this has asked us to display every comparison in the first pass and then the results of a list at the end of its remaining. A pass is just you going along the list of numbers. We're going to have to go along this list of numbers a few times to get it in order. And a comparison is what we're going to do here. So in the bubble sort, what you do is you compare pairs of numbers and see which one is bigger than the other one. Okay. So what I'm going to do is start off with my list of numbers. It's called the bubble sort because or a bubble. So for this first pass, it's the first time we're going along this list. So I first look at the numbers 9 and 6 and I ask myself, are they in the right order or not? These are not in the right order because we're going smallest to biggest. So if they're not in the right order, you need to swap them around. So we're going to swap 6 and 9. Yeah. Okay, so we've done the first comparison of the first two numbers. We swap those around. Then we compare the next two numbers. So we compare 9 and 2. Are those in the right order? So we just have to do this for the first time we go through. And then you can just write the result of the pass. A-level further math. Okay, so 9 and 2. 9 is bigger than 2. So 6 stays where it is, and then we swap for the order of 9 and 2, and all the rest stay there. I should not have written these so big. So we compare the third and the fourth one. So I'm comparing 9 and 12. 9 and 12 are in the correct order, so I leave those as they are. 6 and 2. Ignore those. You'll do that later. So you only go along comparing the pairs. Yeah, we'll do another pass where we go along and then we'll sort of. Now I compare the fourth and the fifth ones, 12 and 11. They're in the wrong order, so I swap those around, leave everything else as it was. So now I'm comparing 12 and 9. They need swapping around. Everything else stays where it is. Then I compare 12 and 3. They need swapping around because 12 is bigger than 3. And finally, I'm going to compare 12 and 7. So I think this is called the bubble sort because your numbers bubble to the end of your row. So we've now got 12 is in the correct position. The biggest number has bubbled to the end of this list. Okay. And I should have given you a warning that you were going to use the next page.
You used
This is the only time we have to do this. So it says display every comparison in the first pass. So I've displayed every comparison that we've done the first time we've gone along this list. Now that I do it, all you have to do is write the result at the end of your bubble sort for this one. Okay. So we're gonna this is pass 1. Yeah. So pass 2. We're taking this list. Yeah, we're going again. So I'll look at 6 and 2. I'm not going to draw the bubbles on this time. They're imaginary bubbles now. And 6 and 2, which is bigger. Well, they're the wrong way around. So I'm going to have to swap those around. So I'm swapping 6 and 2. So I'm putting 2 first. I'm not writing 6 in yet. because I've then got to compare 6 with the next one.
But what?
I can't just write it but yeah.
Then I'm comparing 6 and 9, which is biggest. They're the right way around. So leave 6 where it is. Then I'm comparing 9 and 11. They're the right way around, so they're fine. Leave those as it is. Then it's 11 and 9. They need swapping around. I'll swap 11 and 9. Then I'm comparing 11 and 3. Again, it needs swapping. Then I'm comparing 3 and 7. Needs swapping. So now we've got 11 and 12 are in the right place. I'm going to quickly do the rest of them. I don't want to spend all day doing it.
But I can't do it slowly.
So then comparing 2 and 6. 2 and 6 are the right way around, so that's fine. Leave 2 where it is. Then 6 and 9 in the right way around. So I can leave 6 where it is. 9 and 9 don't need swapping. 9 and 3 do need swapping. Oops, don't want that 9 in yet. And then I'm comparing 9 and 7, which also needs swapping. So that 9 is now bubbled to the end. You end this when you do a pass and you don't do any swaps. Okay. We've got quite a lot that are kind of in the right order at the moment. Keep that. Next one, 2 and 6. 2 stays where it is. 6 and 9. 6 stays where it is. 9 and 3 needs swapping. Then 9 and 7 also need swapping. And then we're done. So all of these now are in the right place. In fact, 7 is also in the right place. Next one, 2 and 6 finds 2 stays where it is. 6 and 3 need swapping. 6 and 7 don't need swapping. They're in the right order. So actually, we know that we've got everything in the right place, but it needs one more pass for the computer to know that it hasn't done any swaps. So go along again, but it will all stay in the same place. It's the right order.